In the last video, we learned about variables and how it's impossible to create any program without them. Whenever we need to store data in a program, we use variables, and often we need to perform calculations with that data. Earlier, these calculations were done manually. Programmers would write the entire code by hand, and then the calculation would take place. For example, if we wanted to find the sum of 10 plus 5, we'd have to manually write the full code for addition, and then use that function to add the two numbers. This was very time-consuming. That's when developers started using symbols to create various operators, making common tasks much easier. This was the moment operators entered programming. Today, in this session, we're going to dive deep into operators, specifically looking at what types of operators exist, what they're used for, and how you can use them. I'll explain everything in detail in today's session. So, let's first understand what operators are. The definition of operators is that they are special types of symbols that perform operations on variables or values. To explain it simply, an operator is a symbol or sign that helps you perform an operation. In other words, we use operators to carry out calculations or comparisons between variables or values. For example, in math, when we put a plus sign between two numbers, we add them. That plus sign works like an operator. It adds those values together. Similarly, in C, operators do the same thing. They perform operations not just with values, but also with variables. Let me give you a simple example. Suppose we have two numbers, 5 and 3, and we want to add them. We can use the plus operator to do this. When we print the result, it'll show 8. But operators aren't limited to just addition. There are many types of operators. With their help, you can perform various calculations and check logic. Operators are a backbone of programming, which is why C has different types of operators. We'll study them one by one, starting with arithmetic operators. Arithmetic operators are the first type, and they include the most basic and commonly used operations. They're used for mathematical operations like addition, subtraction, multiplication, division, and modulus. Let's understand each of these operators in detail. First, we have the addition operator, which adds two numbers. For example, in programming, let's say we take two numbers, int a equals 5 and int b equals 3, and we want to add them. We use the plus operator here, and I've printed the sum. You can see that the plus sign is the addition operator. Similarly, the next operator is the subtraction operator. The subtraction operator subtracts one number from another. For instance, if we have two numbers, 5 and 3, and we want to find their difference, you can see the result is 2. The minus sign here is the subtraction operator. Then comes the multiplication operator, which multiplies two numbers. If we have 5 and 3, their product would be 15, achieved through the multiplication operator. Next, we have the division operator, which divides the first number by the second. When working with the division operator, you need to keep one thing in mind. If both numbers are integers, the result will also be an integer, meaning the decimal part will be ignored. For example, if we have 5 and 2 stored as integers and divide them, the result won't be 2.5 but 2, because integers only store whole numbers. If you want the exact calculation, you'll need to use the right data types like float or double. If you store the result as a float, say float a equals 5 and int b equals 2, and divide them, then store it in a float. You'll get 2.5 as the result. The next operator is the modulus operator, which gives the remainder after division. For example, if we take 10 and 3, when you divide 10 by 3, the remainder is 1. That's what the modulus operator returns. So, that covers arithmetic operators. I hope you've understood them. Now, let's talk about comparison operators. We use comparison operators when we need to check a condition, like whether two numbers are equal, if one is greater than the other, if one is smaller, or if they're equal. Whenever we need to check such conditions, we use comparison operators. These operators return a true or false value. If the condition is correct, they return true. If it's incorrect, they return false. Let's talk about the common comparison operators. The first one is the equal to operator, which checks if two values are equal. If they are, it returns true. If not, it returns false. Let me explain with an example. Suppose we take two numbers, 5 and 5, and check them with the equal to operator. Equals equals. When I print it, you'll see it returns true because both numbers are the same. Now, if we change it to 3 and 4 and check again, it returns false because they're not equal. So, you've understood the equal to operator. The next one is the not equal to operator, which is the opposite. It checks if two values are different. If they are, it returns true. If they're the same, it returns false. For example, with 5 and 3, since they're different, it returns true. But if we use 4 and 4, it returns false because they're the same. Then comes the greater than operator, which checks if the first number is larger than the second. If it is, it returns true, otherwise false. For example, with 10 and 5, since 10 is greater than 5, it returns true. But if we use 2 and 4, since 2 is less than 4, it returns false. Next is the less than operator, which checks if the first number is smaller than the second. If it is, it returns true, otherwise false. For instance, with 3 and 8, since 3 is less than 8, it returns true. But if we use 6 and 4, since 6 is greater than 4, it returns false. Then we have the greater than or equal to operator, which checks if the first number is greater than or equal to the second. If it is, it returns true, otherwise false. For example, with 5 and 5, since they're equal, it returns true. With 7 and 4, since 7 is greater, it also returns true. But if we use 2 and 3, since 2 is less than 3, it returns false. Finally, the less than or equal to operator checks if the first number is less than or equal to the second. If it is, it returns true, otherwise false. For example, with 4 and 6, since 4 is less than 6, it returns true. With 5 and 5, since they're equal, it returns true. But with 9 and 2, since 9 is greater than 2, it returns false. I hope you've understood relational operators. Now, let's move on to logical operators. Logical operators are used to check multiple conditions and establish logical relationships between them. For instance, when you want to check if both conditions are true, if at least one condition is true, or if a condition is false, you use logical operators. We have 3 types of logical operators, which we'll study one by one. The first is the AND operator. The AND operator returns true only when both conditions are true. If even one condition is false, the result will be false. Let's take an example with 3 numbers. A equals 10, B equals 5, and C equals 15. We check if A is greater than B and C is greater than BO. Is 10 greater than 5? Yes. Is 15 greater than 5? Yes. Both conditions are true, so the output is true. But if we change it to A is greater than B and C is less than B, what happens? 10 is greater than 5, but 15 is not less than 5. So one condition is false, making the output false. If we try A is less than B and C is less than B, both conditions are false. 10 is not less than 5, and 15 is not less than 5. So the output is false again. The next operator is the OR operator. The OR operator means OR, and it returns true if at least one condition is true, using the same values. A equals 10, B equals 5, C equals 15. If we check A is greater than B or C is greater than B, both conditions are true, so the output is true. If we check A is greater than B or C is less than B, the first condition is true, but the second is false, yet the output is still true because at least one condition is true. If we check A is less than B or C is less than B, both conditions are false, so the output is false. The OR operator returns false only if both conditions are false. Finally, the NOT operator means not and reverses the condition. If the condition is true, it returns false. If it's false, it returns true. For example, with AI equals 10 and BA equals 5, if we check not A is greater than B, since 10 is greater than 5, true, the NOT operator makes it false. If the condition were false and we applied not, it would become true. I hope you've understood how logical operators work. Next, let's talk about assignment operators. Assignment operators are used to assign values to variables and modify their existing values. The most basic example is one we use often. Int a equals 5. This equal sign is an assignment operator. It's the simplest assignment operator, and we use it repeatedly. There are other operators too, like plus equal, minus equal, multiply equal, divide equal, and modulus equal. We'll go through them one by one. First is the addition assignment operator, written as equals plus equals. We use it when we want to add something to a variable's existing value. For example, if x equals 5 and we write x equals x plus 3, it means we're adding 3 to x and storing it back in x. This is the same as x equals x plus 3. If we print it, since x was 5 and we added 3, the output will be 8. The next operator is the subtraction assignment operator equals, which subtracts from the existing value. If x equals 10 and we write x equals x minus 4, it subtracts 4 from 10 and stores it back in x, giving an output of 6. Similarly, the multiplication assignment operator asterisk equals multiplies the value. If x equals 5 and we write x equals x times 2, it multiplies 5 by 2 and stores 10 back in x. The division assignment operator slash equals divides the value. If x equals 20 and we write x equals 20 divided by 4, it divides 20 by 4 and stores 5 in x. Then there's the modulus assignment operator percent equals, which stores the remainder after division. If x equals 10 and we write x equals 3, it divides 10 by 3 and the remainder one is stored in x. Now, let's move to unary operators. Unary means single, so these operators work with just one variable's value. They're used to modify a single value, like adding or subtracting one. The two main unary operators are the increment operator and the decrement operator. The increment operator adds 1 to a variable's value and can be used in two ways, pre-increment and post-increment. The difference is that in pre-increment, plus plus a, the plus plus comes before the variable, meaning 1 is added first, then the value is used. For example, if a equals 5 and we print plus plus a, the output is 6 because 1 is added to 5 first. In post-increment, a plus plus, the plus plus comes after the variable, meaning the value is used first, then 1 is added. If a equals 5 and we print a plus plus, the output is 5, but a becomes 6 afterward. To remember, plus plus a means add first, then use, while a plus plus means use first, then add. Similarly, the decrement operator subtracts 1 and works in two ways. Pre-decrement double dash subtracts 1 first, then uses the value, e.g., a equals 5, double dash ai outputs 4, and post-decrement, a double dash uses the value first, then subtracts 1, e.g., a equals 5, a double dash outputs 4, 5, a outputs 5, then a becomes 4. I hope you've understood increment and decrement operators. Now, let's discuss bitwise operators. Bitwise operators might seem a bit tricky, but if you know the basics of binary numbers, they'll feel simple. If you haven't learned how to convert binary to decimal or decimal to binary, you should, because without that, bitwise operators won't make sense. You can watch a simple video to learn this. Bitwise operators manipulate numbers in their binary form. Since computers store numbers as zeros and ones, bitwise operators work with these bits. First, let's see how to convert binary to decimal. For example, the binary of 5 is 101, and the binary of 3 is 011. Bitwise operators compare or shift these bits, and the result comes in binary, then gets converted to a number. The first bitwise operator is AND. It's different from the logical AN. It compares bits. If both bits are 1, it returns 1, otherwise 0. For 5, 101, and 5, 101, 3011. Comparing bit by bit from right to left. 1 and 1 equals 1, 0 and 1 equals 0. 1 and 0 equals 0, 0.01, which is 1 in decimal. The bitwise OR operator returns 0 only if both bits are 0. Otherwise, it's 1. For 5, 101, and 3, 011. 1 or 1 equals 1, 0 or 1 equals 1. 1 or 0 equals 1, giving 1, 1, 1, which is 7 in decimal. The exclusive OR, XOR, returns 0 if both bits are the same, 0 or 1, and 1 if they're different. For 5, 1, 0, 1, and 3, 0, 1, 1. 1 XOR 1 equals 0. 0 XOR 1 equals 1. 1 XOR 0 equals 1, giving 1, 1, 0, which is 6. The bitwise NOT operator flips each bit. 0 becomes 1, 1 becomes 0. For 5, 0, 0, 0, 0, 1, 0, 1. NOT makes it 1, 1, 1, 1, 1, 0, 1, 0, a large negative number in decimal, due to 2's complement. Left shift, shifts. Bits left, adding zeros on the right. 5 left shift, 1 makes 1, 0. 1 become 1, 0, 1, 0, which is 10. Right shift, shifts bits right. 5 right shift, 1 makes 1. 0, 1 becomes 0, 1, 0, which is 2. Bitwise operators work on binary and require basic binary knowledge. Finally, let's talk about the conditional or ternary operator, a very useful operator. It's like an if-else statement, which we'll cover in the next video. It assigns a value based on a condition. Its syntax is condition, value, if true, value, if false. If the condition is true, the first value is assigned. If false, the second. For example, with A equals 10 and B equals 5, we want to store the maximum in a variable max. We write max equals a greater than B (B). Since 10 is greater than 5, max becomes 10. If we change it to A equals 5 and B equals 10, the condition becomes false, so max becomes 10. I hope you've understood how conditional operators work. In today's video, I've tried to simplify and explain the different types of operators in C. I hope you've understood them all, but if there's anything you didn't get, or if you have doubts, feel free to ask in the comment section. In the next video, we'll learn about statements and control statements. So, I'll see you in the next video.